A heat pump absorbs 10 kilowatt of heat from outside environment at 250 Kelvin while absorbing 15 kilowatt of work. It delivers the heat to a room that must be kept warm at 300 Kelvin. The coefficient of performance of the heat pump is. First, let's see the definition of a heat pump. Heat pump is a device that works on Carnot cycle and transfers heat from a lower temperature body to a higher temperature body. This schematic diagram shows the working of a heat pump. So let's say this is a heat pump, and suppose this is a cold body at a temperature 250 Kelvin as given in the problem, and now work is done on the system, that is W. In the problem it is 15 kilowatt, and the heat pump transfers the heat to a higher temperature body, which in this case is the room, and that is at 300 Kelvin. As already mentioned, this heat pump absorbs a work of 15 kilowatt, extracting heat from the lower temperature body and transfers to a higher temperature body. Let's say this heat is Q1, which is heat rejected from this heat pump. Therefore, Q1 will be equal to the work absorbed by this heat pump plus the heat it is absorbing from the cold body. Let's say that is Q2. So let's say this is Q2. So this will be equal to 15 kilowatt plus Q2 in the problem is 10 kilowatt. So this will be equal to 25 kilowatt. Now the coefficient of performance or COP of a heat pump is defined as the ratio of heat rejected from the heat pump, so that is Q1 in this case, divided by work absorbed by the heat pump. As we have already calculated Q1 and W is given in the problem, so Q1 is 25 kilowatt and work done is 15 kilowatt. Okay, so this will be equal to 1.67. Now one thing here to remember is COP of heat pump, or the formula of this COP of heat pump, that is heat rejected by the work done, can be used in any type of heat pump. Okay, now let's go back to the problem. So the coefficient of performance is, as we already calculated, 1.67. For more information on heat pump, you can refer to the NPTEL course Efficiency and Coefficient of Performance of Reversible Heat Engines and Heat Pumps on Thermodynamics by Professor Atul Bhargav of the Department of Mechanical Engineering at IIT Gandhinagar.